There we are. Let's do this thing. Welcome to Choose Your Own Adventure, the struggle for security. Meet Hero. Hero is application source code on a developer's laptop. Hero longs to be a real application running in production, serving end users, and we're going to help Hero on their journey. So our job is to help Hero navigate hundreds of CNCF projects, choose which ones to use, integrate them with one another so Hero can live their dream. I'm Whitney, this is Viktor, and together we host a streaming show called You Choose that's on Viktor's DevOps Toolkit YouTube channel. Now, on our show, each episode is a system design choice. And for each system design choice, we bring together all the relevant technology, all the relevant CNCF tools that can do that thing. And then we have a maintainer or an advocate on from each project to tell us about the project. And they only get 5 minutes to describe the project to us. Viktor has a gong. He loves to use it. And so after the end, we put it to a vote. We ask the community to vote about which technology they want to see in our ongoing demo. So our demo environment right now for this talk has choices that you, the community, made. So we have an AWS EKS cluster running. Well, Viktor has a running. It's defined declaratively with cross-plane resources. We have Argo CD doing GitOps, deploying our application. And our application is running. You chose Contour to use for the ingress, so that's what we have going. And then our end users we have the application deployed and end users can reach it. So we did it. Hero's running in production. It's done. What are we doing here? We're done.
I honestly don't know.
So the problem is there's no security in our production cluster right now. So Hero's in danger, the user's in danger, the system's in danger. Bum, bum, bum. So we need your help today. So please get out your phones and scan this QR code. We're going to do some live voting during this presentation. We're going to go through several system design choices, and you'll choose which one you want to see Viktor implement live into an ongoing demo. So we're going to talk about cluster level policy. You can still get the QR code, yeah? Yeah, okay. Cluster level policy, we're going to talk about runtime policy, and we're going to talk about how to manage secret information. And if you didn't get this QR code now, during the voting process, it'll come up again. So we're going to help Hero live their dream and run in a more secure production environment. Not altogether secure, but we do what we can in 30 minutes, right? So admission controller policies are the first thing we're evaluating. The technology we're going to look at is Kyverno, OPA Gatekeeper, and Kubewarden. But first of all, what is admission controller policy or cluster level policy? Well, as things stand, our applications can become bloated and use way too many resources, or they might run outdated versions of things, or maybe they're going to run untrusted container images. So a policy is an organization-specific rule that defines what's allowed and not allowed to happen to certain objects in your cluster. So you might make policies that would automatically add resources, compute limits, and fix that, yep. And we might make policies that declare what versions we use. We might make policies that do the verification of container images before they're run in the cluster. So how does it work? So once you write a policy, then you're adding configuration to Kube API in the form of an admission controller webhook. So at this point, it's only configuration. There's nothing running. You're teaching Kube API. If a request comes in that falls under the jurisdiction of this rule, we're going to send that request to the admission controller. Now, the admission controller is actually software that's running somewhere. And the admission controller can be a validating admission controller or a mutating admission controller. So if it's validating, it's going to return, yes, this is allowed to get made, or no, it's against organization policy. If it's a mutating admission controller, it might change something about the resource and then return the changed resource to the Kube API. But regardless, it's going to give a response, and now Kube API is going to act in accordance to company policy. So let's talk about the tools. So first up, we have Kyverno. Kyverno is a Kubernetes native admission controller. So with Kyverno, so it's built specifically for Kubernetes, and you write your policy in YAML. Kind of. It's actually Kyverno JSON query language, and it's meant to look and feel like YAML with the idea that someone writing cluster level policy is likely going to be comfortable authoring policy and reasoning about policy in YAML. Kyverno has a ton of other bells and whistles, but they're not differentiating, so I'm going to move on to OPA Gatekeeper. OPA Gatekeeper, so the OPA part stands for Open Policy Agent. An Open Policy Agent without the gatekeeper, just OPA, is a platform-agnostic policy engine that you can use across your entire system, not just for Kubernetes things. And so the gatekeeper part wraps OPA up and brings it into Kubernetes, so you can use OPA with Kubernetes-specific resources. With OPA Gatekeeper, you have to write your policy in Rego, which is a notoriously difficult language to learn. So OPA makes a lot of sense if you plan on writing policy across your whole estate, or maybe you already are using it across your estate and you want to use it with Kubernetes too. If you're only using it with Kubernetes, it has a lot of great features, but it does have that initial hump of learning Rego. And then we have some folks who are like, you know what? I don't want to write policy in YAML, and I also don't want to write it in Rego. So let's make a whole new policy engine. And that's Kuborden. Kuborden is a new technology. The other two are graduated projects. I believe Kuborden is, it's Sandbox. Yeah, regardless, what you do is you write your policy in any language you want. It even can be Rego if you really like to punish yourself. And you can put it in a WASM, you compile it into a WASM module, and then the WASM module runs as a plugin to the Kuborden admission controller. And so it has fewer bells and whistles, but it still has a lot of the good stuff, like verifying container images. So with that, it's voting time. Let's do this. What do you want to see Viktor implement? Please, please. OK. I get nervous that the voting software is not going to work.
Okay, it's Kyverno,
It
right?
looks definitive, yeah.
Yeah. Let's do this.
I'm going to scooch off somewhere.
Okay, so what I'm going to do first is I'm going to copy Kyverno YAML into infra directory, and I'm going to call it policies.yaml. And you probably know why I'm copying things to Git first, right? If not, then I don't know what you're doing here. Anyway, so I copied it there so that Argo CD can synchronize it, and while Argo CD is trying to figure out what it is, I'm going to show you what I copied. Here's the manifest. It's a simple one, nothing complicated today. We have cluster level policy that will look for deployments in the namespace production, and it will look only if I update or create a deployment. If I delete, it will do nothing. And it will basically fail if the number of replicas is smaller than 3, or it will be successful if it's more than 2, right? So my deployments need to have more than 2 replicas. And then I have another policy that says, hey, if you have something called cluster SQL claim, which in this case is cross-plane database running in AWS, and if you try to create or update, then that database by the way, I didn't specify namespace, so meaning that this will apply to any namespace. And the field size must be small, medium, or large, right? Relatively simple. And then another policy, cluster policy, again working on SQL claim, but in this case, if it's in production, then it cannot be small, right? And then when you combine all those policies, you get something meaningful. And we're going to see how that meaningful works. And kubectl get cluster policies. It should be deployed. It's deployed. This is very surprising. By the way, is this big enough? Do you see it? You're supposed to complain, not wait for me. OK, is this big enough? Cool? OK, cool. So while I was talking, Argo CD detected the file that I pushed to Git. It deployed it to a cluster. I have my policies. And now I can turn my attention to the application, right? And I'm going to deploy the application in the same way as before, Argo CD, CNCF demo YTT. I'm using YTT today because that's what you chose sometime in the past. And I'm going to put it to this directory. And again, same thing, right? Add, commit, and push to Git, right? So my application will be deployed anytime now. I can double check whether that's really true by speeding up things. Oh, kubectl port forward. There we go. Now I should see my application being deployed if I ever find it. Where are you? There we go, right? So my application now, there we go, should be deployed. Right, so far so good. If this works, there we go. Now, if I go back to my terminal, and I do kubectl -- namespace production, get deployments, there is no deployment, right? And there is no deployment because Kyverno most likely detected that my deployment does not comply with the rules that I set previously. I can see whether that's really true by saying describe. I said describe cluster policy deployment. What's deployment production, right? And if I describe the Kyverno policy, you can see here description. Blah blah blah. Deployment should have more than 2 replicas, etc., etc. Victor, you messed it up. You need to fix it if you want this to happen, right? And I will fix it by changing. Let's do this. Vim YTT. There we go. Values prod. So I'm going to modify YTT values file. I'm going to add here replicas. Should be, how many should I put? 3. There we go. And I'm going to generate YAML with YTT, which is now long command file YTT schema, and file is YTT resources. Yeah, I think so. And data values file is YTT values prod, the one that I changed. I'm going to put this to, I'll put it to YAML, prod up YAML, right? I generated new definition of my application that, among other things, if I didn't mess it up, has 3 replicas for the deployment, right? Now it should pass the policy. And I can just say git add, git commit, git push. And because I'm impatient, I'm going to say, Argo CD, stop doing whatever you're doing, you silly creature. And do it again. And now, if I do kubectl -- namespace get deployments, the deployment is there. Now it passed the policy, right? There is one more thing I need to do, and that's that if I do kubectl get SQL claims, this was also not deployed. The reason, because database also does not comply with the rules of the policy. So I'm going to fix that as well. And I'm going to fix it by, again, executing vim, YTT values prod. I'm going to say the database size shouldn't be small, should be medium. Ah, heck, no medium. You're German, you go big, large. There we go. And same dance again, generate files with YTT. You can see that the database SQL claim right now has the large size. Cool. If I do git add, git commit, git push, I said. You didn't know about command that I cannot pronounce, no? It's the most important command you can have in your terminal, right? I promised I will not say aloud those words, so I put them in my in my terminal, right? Where are we here? Production infra, refresh, and just stop the synchronization. It should be fine. Let's double check. No, not that one. Yeah, not again. Sorry. Get SQL claims. Not yet. Whoa. No, wrong one. I need to go to application. Where is my application? I'm getting nervous. I never did this before. There we go. Sync size status terminate. Okay, yes. Do it again. SQL claims. Still not there. There we go. Works. Successful. Let's go.
The reason he's never done it before is he's never gotten that far in the demo without it breaking.
That's true.
So next up, we're going to talk about runtime policies. For this one, we're going to talk about Falco and KubeArmor. But first, let's talk about why we need runtime policy. So do you trust every single application that's running in your cluster? Do you trust all the internal applications? Do you trust all your third-party tools? Do you trust all of the dependency of all those applications? Do you trust every single process that's running in your cluster? How do you know if just one little process is misbehaving? So that's where runtime policy comes in, or runtime security comes in. So with runtime security, we're looking at what's happening at the kernel level. So we're interested in what's happening during application execution. We're looking for unknown unknowns during runtime. So to do runtime security, first you need to monitor what's happening at the kernel level. Then you can define expected behavior. And once you know what's expected, you can make policy so that something happens when something unexpected occurs. And what that something is depends on the tool. So let's dig right into those. So first up, we have Falco. Falco is a cloud-native threat detector. So Falco can receive inputs, receive events from many sources. There's a Falco kernel module, there's a Falco eBPF probe, and there are Falco plugins. There are 13 different plugins, but it's basically looking at logs like your Kube API logs or cloud provider logs, for example. So with Falco, you use these sources, and then you can create Falco rules. So Falco rules are a set of conditions that, when they're met, they trigger an alert. The alert is just text with some sort of a priority associated with it. And so Falco has some sub-projects that help you do stuff with these alerts. So with the sub-projects, we have Falco Sidekick. That will forward your alert to like 50 or 60. You don't have to use all of them, of course. So whatever you choose, 50 or 60 different compatible destinations. So Slack would be a very popular one for that. Then there's also Falco Talon. Falco Talon will actually take action on alerts. So if something suspicious happens in your cluster, then you can kill a container. Or something suspicious happens in your cluster, and then after it happens, you can start collecting more information, for example. That's Falco. Then we have, and it's a graduated project, and now we have KubeArmor, which is the new guy. So KubeArmor, it also monitors. It does the monitoring completely with eBPF, with KubeArmor. You define your expected behavior and create policy. Then if something suspicious happens, it actually never happens. When something suspicious is attempted, it fails. So with KubeArmor, it happens, and you do something, and then with KubeArmor, it doesn't happen. And that is done, besides with eBPF, it's also done with LSMs, or Linux security modules, which are basically access control modules to the Linux kernel. And that's it. So now it's time to vote. Falco or KubeArmor, what would you like to see?
They're not interested.
Mm-hmm. They're not, with all of these, with a lot of what we're talking about today, the tools aren't mutually exclusive. So KubeArmor is working with Falco so that KubeArmor alerts can also be forwarded to all the Falco Sidekick destinations and stuff. So they're not mutually exclusive.
Okay.
But I think we have, it's KubeArmor it is.
Exactly.
Take it away.
Okay. Okay, so now if I'm in my cluster, right, and if I do something silly like this, namespace, production, I want to execute something, and I want the interactive in terminal in CNCF in this container, this pod actually, and I want to, let's say, list all the files in the root directory, right? I can do that, probably. Nothing prevents me from entering inside the container and doing really silly stuff, right? There is nothing that prevents me from doing that. And to prevent me from doing that, I can annotate namespace production and say kube armor file posture is to block, right? So I want to block stuff from happening. There is also another mode like warn or information or something like that. And overwrite, right? So I'm instructing kube armor, hey, what's happening in that namespace, block it if it's not something that I define that I want, right? And I'm also going to copy this file, kube armor YAML, to the infra directory, runtime policies YAML, and I'm going to, GitOps, git commit push, blah, 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 okay. And soon stuff will be deployed. And while waiting for that to be deployed, I can show you what I deployed, what I will deploy. This is a very simple one, right? Not going anything crazy. Saying basically, if the namespace is production, I want to watch for root directory and everything inside of that directory, meaning recursive, go inside, basically anything, the whole file system, and the process will be allowed if it's /manager, right? So you're allowed to execute /manager process, and everything else is not allowed, right? Whatever is not that is not allowed. You can have many permutations and different things you can do, but this one is simple enough for the demo. And let me see whether Argo CD deployed stuff. Get kube armor policies, I think. Not yet there. Let me help Argo CD a little bit. Come on. It should be fine. Come on, refresh. If it doesn't work, I will blame it on Wi-Fi, not on me. Okay, kubectl port forward just in case one more time. There we go. Come on, Argo CD. There we go. Praise the Lord. Production infra, refresh. Okay, now my kube armor policies should be there. There we go. It's deployed, right? And now, if I do the same thing as before, what was it? You remember when I executed the ls command to list all the files in a directory root? Woo! Not happening anymore. Kube armor prevents me from doing silly things. That's it. That's the short version of it. We have 5 minutes. Go fast. No time to go. All
right, we're going to talk about secrets management. We're going to talk about external secrets operator, secret store driver, and SOPs. So we have a lot of different confidential things our application needs to manage, and a lot of that, we're putting it inside of a vault. So a vault is a place that stores secrets safely and has an API to access it, probably a lot more things like remediation when secrets leak and secrets rotation, but that's not what we're talking about. So what we're concerned about with this problem now is how are we going to get our confidential information from outside of the cluster to inside of the cluster. Now, all three of our tools do this in different ways, so I'm just going to dig right in on the tools. So external secrets operator is a Kubernetes operator that connects to the vault, retrieves the secrets, and stores it as a Kubernetes secret and manages the life cycle of that Kubernetes secret. So now, we have our secret to the application. So it also has a couple of awesome alpha features. It can generate Kubernetes secrets, and it can also take Kubernetes secrets or parts of Kubernetes secrets and push them to the vault, which is great for replicating secrets across clusters. Secret Store CSI driver, they were like, you know what? Kubernetes secrets aren't very secret. They're just base64 encoded and stored in etcd. We can do better. And so they came up with a secret solution that uses CSI, or Container Storage Interface. So basically what Secret Store CSI driver does is it uses the CSI to mount a temporary file system volume to the pod. Then it connects to the vault, retrieves the secret, writes the secret to the volume, and now our application can use the secret as though it's part of its file system. The problem here is that your third-party tools are not expecting to receive secrets as part of their file system. They're expecting Kubernetes secrets. So you probably need to use this in tandem with Kubernetes secrets. But nice try, nice thought. OK, and next up is SOPs. SOP stands for Secrets Operations, but if you call it Secrets Operations, no one will know what you're talking about. SOPs is just a CLI that encrypts and decrypts files. So you have a Kubernetes secret file, you use SOPs, you can encrypt the secret part, and then only whoever you give the decryption key to can read your file. And so in our workflow here, now notice our Vault doesn't have a secret, our Vault has the decryption key. So we can take our Kubernetes manifest, and now that it's encrypted, we can safely check it into Git. And so Argo CD sees the change. We have to teach Argo CD what to do with SOPs files, so use a configuration management plugin, and then Argo CD will know to use the SOPs CLI to retrieve the decryption key to decrypt the file and apply it to the Kube API, and then it's a secret, and now SOPs has it too. This seems like kind of a lot of extra work, like a lot of steps, right? So SOPs, to be fair, SOPs isn't designed for this use case. It's really more just meant to be a lightweight thing so you could share confidential information in between teams and check it into Git. And, and that's SOPs. So those are our 3 choices. Vote, please. SOPs. Oh, I thought they were punking you.
I was almost disappointed. Now it's back on track. Good. There's only one good answer, by the way. Okay.
External secrets operator. Got to move it along.
They change their mind. Yeah, exactly. Exactly. OK, so kubectl
we see we have 2 minutes.
does the Swiss production. Right now, if I list the secret, CNCF demo DB password, this one, right? And I output it as JSON path, and I filter. No, that's the wrong one. The wrong one again. There we go. Data password. Right. Now this is the password I'm currently using. Now the problem with that is that that password is directly in YAML. It's stored in Git. If you go to this public repository, you will find out the password to my database. It's a demo database, so don't waste your time. But what matters is that I'm going to change that by modifying values file again, and I'm going to say that db insecure true, is going to be false. This is just a variable. Behind the scenes, I will use ESO, external secrets operator, with this change, and you will see that in a second. YTT, and now what happened when I generated new manifests. Now I'm defining external secret, and I'm saying, hey, you know what? Go to AWS, find production PostgreSQL secret in AWS Secret Manager, and extract it, convert it into Kubernetes secret called CNCF demo DB Postgres, right? So that's that one. And then I'm going to do the same dance as before. I'm going to copy it first. Argo CD, there we go. CNCF demo YTT. Why am I doing this? I don't know why I'm doing this. OK, yeah, why not? Let me just check. Sorry, I'm getting confused. Yeah, probably it will work. We'll see. Git commit, git push, and now if I refresh Argo CD, I need to be fast because there is no time, not this application. Refresh, come on, come on. Port forward again. How many times do you need? Port forward. OK, let's do it. Cool. There we go. OK, Quick. Go. Come on. I have no time left. OK, maybe I don't need to refresh. Let's say if I do the output, no, come on. If I output the secret, it should be different now. Still not. This is not working. We have no time. Imagine that it worked. And you would have secret from AWS over there.
Put the last slide up, please.
There is more slides?
One more slide.
You get extra time and I don't.
No. Oh, put it on. We're not doing this. No, don't look. OK. No.
Look.
I just.
I don't know what you did.
Yeah. Wow, this is nerve-wracking. OK, now I should just So we have the QR code. One's for you choose the series. The other one is a CNCF. It's a demo repo that if you don't respect your peers' choices and you want to work your own way through what we just did, you can do that with this demo repo right here. So thank you so much, everyone. It's been a pleasure. It's been so fun.